In this video, I'm going to show you how to find geometric means. So in this first example, we want to calculate the geometric means represented by the missing values in the positive geometric sequence 4, 2, something, something, 1/4. And to be clear, what is meant by the term geometric means, it's just a fancy way of asking for the missing terms in between known terms of a geometric sequence. So really the problem is just asking us to find these missing terms in this geometric sequence. So how should we do this? Well, remember that a geometric sequence just involves multiplying by a common ratio every time to get to the next term of the sequence. So 4 times some number r is 2, and then 2 times some number r is the next number, then times r again, and so on. And we know the first two terms of the series. We know the first two terms of the sequence. That's just 4 and 2. And we know that 4 times r is equal to 2. So we can solve for what r is here. So r, we just divide both sides by 4. So r is 2/4, which is just a half. So we're multiplying by half every time. So now we can just continue multiplying by half to find the missing terms. Okay, so the first missing term here, this term comes from taking the number 2, the term before it, and then multiplying by r. So 2 times a half, because r is a half, and 2 times a half is just 1. So that's what's going to go in that missing box here. And then to find the next missing box, we're just going to find we're going to use the same method. We're just going to start with the number for 4. So start with 1 and then multiply by r to get to the next number. And then so that's 1 times a half, and 1 times a half is just a half. So we'll plug that in right here, a half. And to check ourselves, we can also look at the last term, 1/4. That should match up if we take that preceding term, a half, and multiply it by r. So half times r is a half times, well, r also is a half, and a half times a half is 1/4. So yeah, the 1/4 matches up, and we can be sure that these are indeed the correct missing terms. So great, we're done. So here's a problem that's pretty similar to the previous one. Again, we want to calculate the geometric mean represented by the missing value in the positive geometric sequence 3ak, that's our missing value, and 48. And again, since this is a geometric sequence, each term, to get to the next term, we just multiply by r. So 3 times r makes ak, and then ak times r makes 48. But this time, we don't know any consecutive numbers, so we can't just simply divide them to get r like we did last time. So how are we going to get r this time? Well, why don't we look at both of these pairs of numbers, 3 and ak, and then ak and 48. We can write down an equation for each of them. We can write down that 3 times r makes ak. So write that down, 3r is equal to ak. And then the other one is that ak times r equals 48. So let's write that down. ak times r is equal to 48. All right, so is there any way that we can solve these equations for r? We've got two variables, two equations, so we should be able to do this. And indeed we can. Look, we have ak is 3r according to this equation, and we can just substitute that into this equation here. So let's take this equation here. We know what ak is, and we'll just substitute that in for ak there. So ak is just 3r, write that down, 3r, we'll put an r inside of those parentheses also, 3r, and then times r is equal to 48. So let's simplify this a bit. This is just 3r times r is just r squared. So 3r squared is equal to 48, and we can divide both sides by 3 to get that r squared is just equal to 16, and then to cancel out that square, we can just take the square root. So r is equal to plus or minus square root of 16. which is just plus or minus 4. So we've got two possibilities here. Either r equals 4 or r equals negative 4. And how can we tell which one represents this sequence here? Well, remember, it is a positive geometric sequence. So that means the common ratio also has to be positive. If it were negative, then the terms would be flipping back and forth between positive, negative, positive, because we'd be multiplying by a negative every time. So r can't be negative 4 since it's a positive sequence. R has to be 4. Okay, so now that we know that r is 4, it's pretty easy to compute AK. AK is just equal to 3 times r. And we know what r is. R is just 4, so this is really just 3 times 4. And that tells us AK is just 3 times 4, which is 12. So there we go. AK is just 12. And that's our final result. That is our missing value. Again, we can check our result by also looking at 12 times 4 should make 48. And yeah, indeed, that's true. So we can be sure that our result is correct. All right, here's our last example. We want to calculate the geometric means represented by the missing values in this positive geometric sequence 5, x, y, z, 80. So this is a positive geometric sequence. We've got 5 values here, but we're missing 3 of them. So we want to solve for what are x, y, and z in this geometric sequence. Well, again, we know we're just multiplying by a common ratio every time, times r, and then times r, and then times r, and then times r again. So how can we figure out what x, y, and z are? Well, it's easy if we can figure out what r is, so how do we figure out what r is? To figure out what r is, why don't we use the formula for the nth term of a geometric series? Remember, the formula is just an is equal to a1, the first term, times r to the n minus 1. And let's go ahead and label our terms here. 5 will be a1, x will be a2, y will be a3, z will be a4, and 80 will be a5. So let's write down this formula for a5. So a5, that's when n is 5, that equals a1 times r to the 5 minus 1, which is just a1 times r to the 4th. And we know what a5 and a1 are. a1 is just 5 and a5 is 80. So let's substitute that into our equation here. So a5 is 80. 80 is equal to a1, which is 5, times r to the 4th. And we can also see that looking at our times r times r times r times r. We're just multiplying times r 4 times, so that's r to the 4th, going from 5 to 80. That makes sense. That's what our equation says here. Okay, so let's, this equation makes sense, so let's just solve it for r. We'll divide both sides by 5. 80 divided by 5 is just 16. So 16 equals r to the 4th. Okay, so we can take the 4th root of each side, and then we get the 4th root of 16 is equal to r, plus or minus the 4th root. Okay, so 4th root of 16 is just 2, because 2 to the 4th is 16. So we got plus or minus 2 equals r. So does r equal 2, or does r equal negative 2? Well, again, this is a positive geometric sequence, so all the terms have to be positive. We don't want any flipping from positive to negative, so that means we can't have the negative common ratio. And our common ratio is just r equals 2. Okay, great. So now that we know that, we can figure out what x, y, and z are. So x is just 5 times r. So x is 5 times r, which is just 5 times 2, because we figured out what r is. So x is just 10. Okay, so let's box that. How about y? What is y? Well, y is just the previous term x times r. Y is x times r, and this time we know what x is. X is just 10, and then multiply that by r. R is just 2, so y is just 10 times 2. Y is just 20. Okay, box that. And then z again is just r times the previous term. So z is previous term y times r, and so let's write that down. Z equals, well, y we just solved for, that's 20, and then r we know is 2, so 20 times 2, so z is just 40. Okay, that makes sense. And then just to double check ourselves, z times r should make 80, and indeed 40 times 2 makes 80. So yeah, we can be sure that we're correct. In the future, we'll continue learning more about geometric series, such as determining when they converge and diverge.